All right, so as always, every single test, we need to have a question about finding our tangent line. So remember the tangent line, what we do is we have our point slope form. So we start with y minus y1 equals our m, which is our derivative evaluated at x1 times x minus x1. And I think it's really important not to just memorize the formula, but remember you're plugging in your y1, you'll plug in your derivative evaluated at a point, and then you'll plug in your x1. So usually they give you the x1 at least, and so in this case the point is given as 0, so we'll plug that in, and then the y value is given as 3. So the main work and objective is really going to be about finding that derivative and then evaluating it at that particular x value. So in this particular case, what we would have to do is we would first take our derivative, and that's just going to be the derivative for any x. Now, you'll notice that our original function has an e to the 3x. So to take its derivative, we're going to have to use the e to the u times u prime rule. So we'll have e to the 3x, and then we need to multiply by the derivative of 3x, because that's a linear term. That derivative will just be 3. Again, x to the first, we'll just get the coefficient. Now, we don't plug that in for our f prime of x because our f prime needs to be evaluated at the given x coordinate. So my given x coordinate is 0, so I will plug in 0 into my derivative. So I have e times 3 to the 0 times 3. So all of this e to the 3 times 0, that will become 1 because we have e to the 0, and then times 3, giving us 3 for our derivative evaluated at 0. So we will have 3 here. And if you needed to for some reason, what you could do is you could solve for y. So our tangent line is currently looking like y minus 3 is equal to 3 times parentheses x minus 0. So what you could do is you could say this is y minus 3 equals 3x minus 0, which is of course not need to be written, and then add 3 to both sides to get y equals 3x plus 3 as our equation of the tangent line.